Right, in this descriptive geometry over here, they're asking us to find the true length of the line AB. This is the top view, that's the front view. The front view is on the vertical plane, the top view is on the horizontal plane. They say that they want you to get the true length using the projection method, and they want you to find the true inclination of the line segment AB to the horizontal plane. Now, if they want you to find the true inclination of the horizontal plane, you must work off that horizontal plane, finding a new XY axis to that horizontal plane. Now, this one's particularly easy because you should be able to get your set square lined up. It's an equilateral triangle, which means that I know that that's a 30-degree angle. Very easy. I can slide my set square down over here. I can draw in an XY axis over here, labeling it X and Y. Put the 1 and the 1 over there. I can now take my set square and I can draw lines coming out at 60 degrees over here. And I know that they are going to cut over that XY axis perfectly at 90 degrees. You can see the 90-degree angle over there and over there. Right, if I've got that, it means that I'm looking at my line at 90 degrees, which means that whatever's shown over here will be a true length. To get the lengths that I need to transfer, I'm just going to draw some construction lines down from A over there and from B over there. And I'm going to measure this distance from A up to there, take that measurement, come down to the new XY axis, plant it down over here. I can see that I didn't extend that line out enough. And then I take this measurement over here from XY axis to B, find B1, go down to the new XY axis and measure that off over there. So I have B over there and A over here. It's going to extend that line out so that we get the intersection correctly. There we go. Okay, once I've got that, I can then draw in this angle over here. This line over here, and then we're going to be able to measure that angle. The angle, I take my set square and I draw a construction line parallel to the XY axis over there, and I'm going to be able to measure this angle over here, which is going to be the true angle of inclination to the horizontal plane. Right. Okay, remember that, working off the line on the horizontal plane in order to get the true angle of inclination. That's easy enough. I'm just going to take this protractor over here, pop it over there, get that all beautifully lined up. Let's just do that, and I end up with, on this protractor, 69 degrees. So I'm going to write that down. Theta equal to 69 degrees. You'll see that I drew a little angle in there, labeled it theta, and drew in a little curve over there with little arrows. And then I can measure that off over here. Take this measurement of the true length. Let's measure that one. Measure that off on my ruler over here, and I'm ending up with 60 millimeters. 60 millimeters. There we go. That's that one done. Same story over here, except this one is set at the 45 degrees. So I can then take my set square, my 45-degree set square. Same story, nice and easy. Take my 45-degree set square. You can see that that's lined up on this line AB. Shunt it out over there. Draw a XY axis, X1, Y1 over there. Take some construction lines coming out from A and from B over there. Take a construction line coming down from A and from B just to get the distances over here very accurately done. Measure off that distance from the XY axis to A over there. Find A, come down to the new XY axis, mark that off over there, label it as A, find B over there, measure that off, find B1, go down to the new XY axis, label that over there, B, take a line going from A to B over here, and you can then take your set square that's lined up with that. I can draw a construction line coming out from B over there. I'm going to draw in a little arc going around over here with arrows on either side of it. Label that as theta, and you are then going to measure what that angle is with your protractor. Take your protractor, place it over here. Let's just get that in the right orientation. Get that over there. Measuring out all the way over here, and I end up with 67 degrees or something like that. So I'm going to write that down. Theta equal to 67 degrees. And the true length of this line, just need to measure that off over here. Take my ruler, measure that off accurately over here. And I end up with 58 millimeters equals 58 millimeters. Right, next one. This one's a little bit more tricky because the line is not at a nice 30-degree angle or 45-degree angle. So what I'm going to suggest that you do there is you're going to take your set squares. You're going to line them up on that line. Get that nicely lined up on that line AB over there. And you're going to slide that down. You're going to draw in an XY axis over here. Label it X and Y. Let's make sure that that doesn't move around too much. Right. So that line and that line are parallel to each other. Slide that back a little bit. Take your other set square around over here, and you can now draw in construction lines coming down from B over here. Just a nice construction line coming down from E over there, and slide that across to A over there. Hold that down. Draw that out there, and I can then take these measurements from A and B. Let me just find them accurately. Draw a construction line coming down from B down to B, A down to A. I can then measure these distances from the XY axis to where B is, find B, go down to the new XY axis, mark it off, label it as B, go up to from the XY axis up to A over there, find A, come down to the new XY axis, mark that off, label it as A, draw in the line going from B to A over here, take your set squares, again, line your set squares up on that XY axis, that, slide that back, draw in a construction line over here, and you're going to measure off this angle over here in order to find the true angle of inclination to the horizontal plane for AB. There is theta, pop that over there, theta is equal to, and measure off that angle. Let's just find that there. Let's get that accurately sorted out, and I end up with, looks like 60, yeah, about 60 degrees. I'm not sure whether that's 100% right, but about 60 degrees. There we go. And then the true length, I just need to measure that off. Take my pair of dividers, measure that off accurately using the dividers, measure that off on the ruler, and I end up with 49 millimeters. So I can write that in 49 millimeters. Right, this one I'm going to do slightly differently, just to show you the other method of getting the XY axes and all that. I'm going to start out, otherwise it gets a little bit complicated later. Just draw construction lines from there and construction lines from there. Once you've done that, take your page, release it from the board. You can use your set squares like we did in the previous one, but this is just another method of getting this. Take that off, get your set square lined up on that line AB. Let's just get that nicely sorted out over there. Right, let's get that. There we go, that's all nicely sorted out there. Stick it down with your masking tape in 2 places. You can now draw a line which will be parallel to the AB line over there, X1, Y1. Draw some construction lines that will be at 90 degrees to the XY axis and to the line AB over there. And then you can measure off the distance from XY axis to B. Find B, go to the new XY axis, mark it, label it as B. Go to the XY axis, go to A over here, go down to A, go down to new XY axis, mark it, and label it A. Draw in the line from A to B. Draw in a construction line which is parallel to the XY axis over there. Over there. Draw in a little arc going around like that with arrowheads. Label it as theta. Go over here, theta is equal to, and you can now measure off that angle using your protractor. Get your protractor lined up over there. And measure around, and I end up with, it looks like 62 degrees, so I'm going to write in 62 degrees. And then I measure off that length over there. And I end up with that on my ruler, which is 47 millimeters. 47 millimeters. Right, there we go. That is that drawing done. Good.